This is pretty spooky, huh? NET-201. This is, well, not Wednesday. This is actually Monday and Wednesday, but this is Monday, 30th. We had a question and answer part to begin with. Okay? So, yeah, make sure you are attending and participating in the course. If you need some help, let me know. Let's move through this. So then, yeah, here on Monday we talk about IP6, link local, global unicast addresses. These are two key ones in our configurations. We looked at some links in my computer, and we talked about this here scope ID. We talked about that, and we also looked at Linux machine. Looked at the same thing. Talked about addressing, the bits, and so forth. Okay. The split, right? 64 bits for the network part and 64 bits for the interface. That's an A interface. I mentioned all the Internet of Things, all the things we can assign to that. So the addressing is 128 bits total. And a lot of times this network will be split. 48 bits will be supplied by the some network address supplied by the ISP, and then a big company can take that and subnet that, right, 16 bits, and then they have these 64 bits for the interface for each individual device. So you can just imagine we're not going to be running out of addresses. Right, we did a little work looking at some addresses, and the lab on this did a nice job. Students had an opportunity, plus I posted the key for the students who did the work on practicing the compression of the labs and decompression. Okay. Time to move to the next page. Talked about the public address, our public address on campus. Talked about public and private addresses. We talked a little bit about the lab work here. This is where I reviewed this router. Okay, this router is doing network address translation. So it converts all of our 192.168 addresses to a 172.21. And it allows us to communicate out to the firewall. There's actually, I should make note here, there's actually some devices in between there before it hits the firewall. Okay? And then here's our multi-layered switch, which then distributes out to each of the networks. So I used 109, here I use the example 109. Let me highlight that. So now you can subnet this into networks, and we subnetted into 4. We only use 3. So then this device knows if it sees this network, it's going to send it to this router. So if I was to do another example, let's say I had a 192.168. Let's just make, okay, let's use one we have, 102.0 / this device would send all the addresses for that this way. And even though once they got here, let's say we have this router. This router, since this is subnetted, it's going to send it to the correct place here. We can review this some more as we keep moving through, because we're going to keep those routers and switches here for a couple more weeks before we reconfigure them. More on IP6. Let's see if we can decipher this screen without spending too much time. We have unicast, multicast, anycast. And then these unicast addresses, they split out into different classes of addresses. You get it? So, yeah, it's a little bit confusing at first, but the more we work on it, the more you'll understand it. We did automatic addressing with the other class, in which your devices would automatically get their own address. Okay? So, I already talked about this. Prefix, right? Typically 64 bits. We take the 128 and split it in half. Usually the subnet 16 bits and the provider the 48 bits. And we talked a little bit here about access points and devices getting their own addresses. Okay, and two ways of doing that, right? You can use the physical address of the device. We'll talk more about that later. Or it can assign a random number. One last thing here, we talked about IP4, broadcast, and so forth, and then IP6 is different in those respects. It has a unicast, a multicast, but then it has an anycast, doesn't have a broadcast. And we don't go much more into that at this point. Your career, whatever I mean by that. Okay, IP4, IP6, we talked about the differences and looking at them. We went over that variable length subnet masking, if we would divide there. I think this was another example, okay, right? We talked about the network part and what we can do with the part there. Request for comment, 1918. That's the private addresses, which is really different in IP6. We talked about the global, and then we talked about unique local addressing. These are not, they're like private addresses in IP4, but they're not really the exact same. So it'll be, we looked at some more examples of those as we move on through. Now, to try to, I can keep the same color. On our routers, when we did our variable length subnet masking, we talked about you could divide up a network, and reasons why. You can have policies to determine which traffic can go here, which traffic can go here, and which traffic can go here. Maybe this is the students, maybe we have servers over here, maybe we have a place for teachers over here, and this will make a lot more sense. You know, we have subnets that we made with the address we already have. This will make more sense too when we get to VLANs, and it looks like we'll be covering that this summer in the networking class. We'll have a networking class in June. In June and the beginning of July. And finishing up this day, I'll try to be, we had IP6, we already talked about these, and I think this is a repeat slide. hey, this is Wednesday. Networking. April 1st, right? April Fool's Day. I didn't do any April Fool's jokes, but I did say white rabbits. So the first part of class, you were to check your work. I made some comments. Everything was checked. We talked about recording, and Zoom's going to convert over to automatically Panopto recordings, and so you'll have one link, so you'll find the recordings based on that. We did some work. Lab variable length subnet masking, and later on we did IP6. We talked a little bit about address being distributing them. We had a denial of service in our firewall. We could have maybe used a region to block other regions. And then here we talk about those unicast addresses, right? We have the global, we have the local, and then we have the unique. So we have an example where we use that. Right here I was talking about our address. They were trying all the possible numbers here with all the possible ports, and they were trying to hack in, see if they could find something open. So one that, if one that is open is 185 port 22. I didn't mention that in class, right? That one's open because that's the one we allow people to come in to get to the work server. So then you want to make sure your work server has good passwords, changing them and all that on the root. Yeah, maybe they hacked in. I was going to say maybe they hacked into your account on the work server. Same day, here we talked again about subnetting, our variable length subnet mask. We talked about the multi-layered switch is looking at this address as another example. The router is just looking at, let me use another color. Let's say green. The router is just looking at this much, so it pushes those addresses here, and then the switch here in yellow, it looks at this part of the address, so it knows which router to send it to. And then the router, let's say blue, it looks at these subnets, and those subnets are going to tell it where to send the traffic here. Then what we did, I'll highlight this, we used IP6, and we looked at this scenario here where we have IP6 running on this network, another group of routers. Anyway, what did I do here? What did I calculate? Calculate the mask for this subnetting here /26. Yeah, we talked a little bit IP, the interface address, either them uses the physical address or a random number connecting PCs to the network. Here's our scenario. We came back 9:50, April 1st. We talked about the network addresses, and currently they're distributing this. That's why we get this 2 here at the beginning. Extended unique identifier. Adds this, adjusts bit 7, inverts it to give us this part of the address, right? So this is the network part, first 40 or 64 bits, and then we have another 64 bits here for the interface. Okay. And we talked about these networks here. We use this as an example. I'm going to keep moving. So this is, this is a repeat of what we just talked about. This is a repeat. So basically, that's a wrap on today. What I'll do is we'll call it a wrap. That's it.